engineering properties and cost performance of normal and high strength concrete containing waste material. It will be presented by Fuad ABUTAHA. Yes, please.
Okay, good afternoon, ladies and gentlemen. I am fine today presenting my research outcome, which is entitled the assessing of engineering properties and the cost performance of normal and high strength concrete containing a waste material. My name is Fuad ABUTAHA, and I'm presenting University of Malaya Department of Civil Engineering, where this research conducted. So we move forward to the background and the introduction for the research. As you know, Malaysia is one of the primary producers of the palm oil, and it produces more than 18.7 million tons of palm oil annually. But unfortunately, the production of the palm oil industry it's also a major contributor to the pollution problem occurring in the country, and with a significant amount of waste are produced as a result of the palm oil production. So the high amount of the waste majority of them are composed of the palm oil clinker and oil palm shell. My research are focused on the palm oil clinker, which is one of the major waste, because we have different type of waste, but majority of it is palm oil clinker. So the palm oil clinker is a byproduct resulting from the palm oil shell incension in the form of solid fibrous material. It's a green color, as you can see. It's a green color. The appearance, it's porous, fibrous, flaky, irregular shape with sharp and rough broken edges, as you can see from the picture. So initially, from my point of view, when I started this research, POC, this waste material, when it crushed, possesses the potential to be as aggregate in the concrete production. So the material preparation, starting from the palm oil mill waste. This is the palm oil mill waste in the factory of the palm oil production. This was collected in a large drum, and then this material was crushed using crushing machine, and then sieved to be used as coarse aggregate, fine aggregate, and it is also grind to be used as powder form. So we have the same material, coarse aggregate, and also fine aggregates, and in a powder form as a filler material. So the experimental program, we have two grades of concrete. We have normal grade of concrete, which is 40 megapascal, high strength of concrete 90 megapascal. So the replacement of the coarse aggregate, natural aggregates with this waste material was conducted in both grades, normal and high strength concrete, to assess the effect of this waste material in different grades of concrete. So we have two grades, normal and high strength, and the replacement was conducted in a volume, replacing by volume. The replacement level ranged from 0 up to 20, 40, up to for replacement for the coarse aggregate for the both grades. And because the properties of this material, it is as you see, it's a very lightweight material, porous, a lot of voids. The sharp broken edges has negatively affected the engineering properties, the fresh and hardening properties of the concrete. So this is the first experiment that was conducted. We have observed that it is negatively affect the concrete, the fresh and hardening properties. After that, we use the particle backing methods were adopted to measure the voids, the volume of voids of this material, and this voids was filled up with the powder of the same material. So this material, initially we use it as coarse aggregate. It has a negative effect on the friction hardening properties, and it was attributed to the porous, natural porous of this material. And then the same material was ground and added, incorporated to the mixture to fill up the voids of the concrete. So determine the steps of determining how much volume do we have for each replacement level of the coarse aggregate. We use a particle packing method. So the steps of using particle packing method: first, all the aggregates were prepared in a saturated surface dry condition. Then the combination of all the aggregates was prepared based on the mixed proportions, and then the mixture were placed in a known volume of a container, all the aggregates, the sand and the POC and natural aggregates for each replacement level. Then a known volume of water was prepared, and subsequently the water was poured in the container until it reached to the top. So this process was conducted for each replacement level of POC, from 20, 40, 60 up to 4 replacement, to measure the voids volume in the mixtures. And lastly, the amount of water used for each replacement level represent the total voids in the mixtures. And of course, with low percentage, low level of POC coarse aggregate does not consume like the water used in the low level of POC contents will be less than when we use high volume, high percentage of POC coarse aggregate. So the amount of water used with low level POC were lower than the water used in the high percentage of POC content in the mixture. So this is the mixed proportion for normal concrete. The first series direct replacement without any adjustment, and the second after incorporating the POC powder. Okay, particle packing method was used to measure the volume in the mixtures. Then the equivalent volume, we use a POC powder, the same material in a powder form, to fill up this volume. So here, for the purpose of comparison, this is the mixed proportion for normal concrete with and without the POC powder for normal, and this is for high strength concrete with and without POC powder. And we have also this study also investigate the engineering economic index. The study was designed to analyze the cost comparison between the conventional aggregate concrete with the new proposed concrete, POC concrete. And the cost comparison was based taking in the consideration of the local or the current market cost of the material. And we use this formula to measure the index, engineering economical index. So the results for the compressive strength, the first observation when we direct replace the POC coarse aggregate, we had like a reduction in the compressive strength. The compressive strength decreased with the increase of the replacement level. The maximum reduction was at full replacement, which registered a value of 30% lower than the control for the normal concrete, and 40% the strength decrease for the high strength concrete. But after incorporating the POC powder as filler material to fill up the voids of the POC, we have a significant improvement in the compressive strength as compared to the mixes without filler material or without POC powder. So the compressive strength was increased in the range between 20 to 30% compared to the mixes without POC powder, and for the normal, and from 0 to 13% for the high strength concrete. This is compared with the mixes without the filler of POC. The same trend also was found for the splitting tensile. There is a reduction when incorporating POC coarse aggregate. The high contents of POC coarse, the lower value of splitting tensile, and the maximum reduction was at full replacement, which was just a value of 27% for normal strength and 32% lower than the splitting tensile of the control concrete. But after incorporating the POC powder as filler, there is an significant increase in the splitting tensile, and this is the range of the increment compared to the mixes without POC powder. And also the same trend for the flexurer, and this is the percentage of the reduction, but after incorporating the POC powder, there is significant increase in the flexurer strength compared with the mixes without POC powder. The water absorption, because as I have just mentioned, this material is porous material with a lot of voids, so it tends to absorb more water. So with the increase of the POC contents, the water absorption was increased. But after incorporating the POC powder, there is a significant reduction in the water absorption, and this is attributed to the the reduction of the water to binder ratio, because the POC powder, the filler, was additional, is not a replacement of any material. The chloride resistance, rapid chloride permeability test, it doesn't show any difference between the mixes with the POC coarse aggregate. It was comparable with the controlled concrete, but after incorporating the POC powder as a filler material, there is a significant reduction in the chloride ion fast column. For the high strength concrete showed that POC mixes, but for the high strength concrete, there is no difference between all the mixes in terms of the resistance ion rapid chloride permeability test.
Fuad, you have 1.5 minutes to conclude.
So for the cost analysis, the total material cost for all POC mixes were lower than the control mix. So the using of POC, which were cheaper than the natural aggregate concrete, and the reduction and the high percentage of use is the cheaper, and it was 18% cheaper than the control or the natural aggregate concrete for normal concrete production, and 7% lower than the high strength control of high strength concrete. Engineering Economic Index for normal POC content, ECI, showed greater value compared to that of control concrete, and at the 20% replacement of the normal aggregate concrete showed the higher index value, and this is attributed to the low cost in addition to the satisfactory structural efficiency. So in conclusion, POC is a waste material generated in large quantity, and when it crushed possesses the potential as aggregate in concrete production. POC is highly porous material, has a negative effect on the engineering properties fresh and hardening properties of the concrete, but adopting the particle packing methods is beneficial to measure the volume of voids in the mixtures, and incorporating additional powder, POC powder, significantly improve the fresh and hardening properties of the concrete. And the engineering properties of POC concrete, POC powder, do not deviate from the properties of natural aggregate concrete, and there is a great potential for the use of POC cores in normal concrete production. So the novelty and contribution of this research, incorporation of the POC serves as a venue to reduce the volume of waste, which would pave the way for achieving sustainability in concrete production. Natural resources can be conserved significantly by reducing the usage of its usage, and also by substituting them with waste and byproduct. And lastly, the low cost and environmentally friendly POC aggregate provide an alternative normal aggregate for future use. Thank you for your attention.
Unfortunately, we don't have time for questions. I think discussions can be done after the session. Thank you.